Hi everybody. So in this video I want to introduce a new piece of equipment, which is the breadboard. So the breadboard is a really handy piece of electronic equipment that we use for a lot of our circuit building and circuit prototyping. And if you recall in our last video we made that simple incandescent light bulb circuit using the 9-volt battery and the alligator cables. And the alligator cables are just kind of dangling all over in space. Everything's kind of clipped on. Not the most compact, not the cleanest or most durable type of circuit. So the breadboard will allow us to fix some of those problems and make really nice, clean, organized circuits. So let me show you a little bit of how they work. And to do that, let me look at this wire here. So this is a typical jumper wire. Consists of flexible wire in between and some rigid exposed wire here. And what you can do with the jumper wire is you can take it and you can plug the rigid parts into the breadboard. And now I've jumpered this point to this point. And to understand this a little bit better, I've got a secondary breadboard, bring in. And I've taken off the back of that breadboard so you can see what's going on inside. So let's take a look. And the first thing to look at are the so-called power rails, which are these long rails on the side. And there's two power rails, a positive and a negative. And if you look on the back of the board, you'll see they're connected with these long conductors. So that means if you look at the negative rail, every plug on the negative rail is connected to every other one via this metal rail. And you remember metals are conductors, so charges can flow freely through that piece of metal. You'll also notice these rows are also connected by a metal conductor, so every point on the row is connected to every other via a wire connection via this metal conductor. You'll notice this trench here though separates the different rows. So the points on this row, while they're connected to each other, are not connected to the points over here. And so this is a really useful configuration for the board, and you'll see as we build some circuits how this is used. So let me bring in the battery again, and I'll show you how you would connect the battery to the breadboard for use in our circuits. So now that I brought the battery in, you recall we're using a regular 9-volt battery. We've got the negative and the positive terminals. Instead of connecting this with the alligator cables, I'm going to use this new connector, which has these snap-on connectors. These snap-on connectors will snap onto the battery, and then you'll have the positive terminal on the red cable, which terminates here. I'll be able to plug that into the positive rail on the breadboard. And the black cable, again, I'll be able to plug into the negative terminal of the breadboard. So let's set this up, hook the connector to the battery, plug it in, and we'll see what we've got. Now that I've got the battery hooked up, you can see I've run the red connector into the positive rail. So every single one of these points on the positive rail is connected directly to the positive terminal of the battery. And I've got the negative end run into the negative rail. So every one of the points on the negative rail are connected back to the negative terminal of the battery. Now to use this, we're going to make a simple LED circuit. So I've got an LED here. There's a nice red LED. And you're probably familiar with LEDs from everyday life. You see them a lot in light bulbs and flashlights, things like that. LED stands for light emitting diode, and they're going to take the place of the incandescent bulb that I used in the last video. The way LEDs work is whenever current runs through in one direction, it will light up, and current will only run through the LED in one direction. It won't run through in the other direction. So LEDs are what we call polarized. That means you have to have one of the legs connected to the positive side, and the other leg then has to go to a more negative side. The way you tell that is if you notice one of the legs is longer than the other. the longer leg is going to go to the more positive side and the shorter leg to the more negative side. Now the other thing about the LEDs is they have very low resistance. So if you just hook the LED up across the battery, you'll send lots and lots of current through it and burn it out. So we have to add an extra resistor. That's what this guy over here is. This is a electrical component whose only purpose is to add resistance to the circuit. So this will slow the current down through the circuit and prevent us from burning out the LED. Let me go ahead and hook this circuit up, and then we'll see how it behaves. Now that I got the circuit hooked up, let's go through and trace the current and see if we can understand what's going on. So we've got from the positive terminal of the battery running through the red wire, then along the rail to the resistor. Resistor, of course, is limiting that current. Current will run through the resistor, where it is connected to the LED via the fact that it's plugged into the same row as the positive leg of the LED. Current runs through the LED, back down into the negative terminal, and then back to the negative of the battery. And this allows the LED to have current running through it and allows it to turn on and give off light. Once again, the LED is polarized, so if I were to take the LED and flip it around so this leg is over here and this leg is over here, then you would not have any current flowing and the LED would actually block the current. So this is a really simple circuit to start getting some practice with the breadboard and see how you can use it to make circuits. I want to show you next, I want to show you another way you can power it rather than through this connector. That's sometimes a nice way to do things. So this is another device here that we can use to introduce power to our breadboard. This is from the Elegoo Arduino Super Starter Kit, and it's a real handy little power module. And the way it works is we have another 9-volt plug, so this here will snap onto the battery, and then this plug will plug into here. Once that's plugged in, we can control it by turning either on and off with this switch, and you'll get a positive negative here and a positive negative here, which if I flip it over, those are going to correspond to these header pins. And what I can do is I can take this and I can plug it into my breadboard. And you have to be careful that you line up the positives and the negatives. So you can do it backwards, like that. And the other thing to watch out for is you have these jumper pins. And you can select, depending on where these jumper pins are placed, between 3.3 volts and 5 volts. I like to have them both at 5 volts. That's a really standard voltage that we can use a lot. So now that we've got the battery hooked up, I can turn on the power with this switch, and the same thing happens. I can run the LED. This is really nice because it gives us 5 volts. 5 volts is a very standard voltage that we see a lot. And it also gives me a convenient on and off switch that I can use to turn my circuits on and off. So this is a basic introduction to the breadboard and getting power to the breadboard. The next thing we'll talk about is resistors. We'll talk about resistors in a little bit more detail and go over some of the color codes that you see with the resistors.